Ryan's office revenge.
The projector clicked off, and 30 pairs of eyes turned to stare at me. Brady Ashford stood at the front of the Ford conference room, pointing his laser at the slide that showed my name crossed out in red. Garrett's quality protocols are why we're losing contracts to overseas suppliers, he announced. Frankly, his approach is obsolete. I'm Garrett Whitfield, 47 years old, and I've been running quality control at TechCast Manufacturing for 23 years. I started on the floor when we made 200 parts a day. Now we push 15,000 aluminum castings daily for Ford's F-150 trucks. But sitting in that presentation, listening to the kid I'd trained dismiss everything I'd built, my safety glasses fogged up from the heat crawling up my neck. The tolerance specs don't lie, neither do failure rates. But Brady wasn't talking specs, he was selling a story about streamlined processes and efficiency optimization. 3 months ago, this same Brady was my intern, asking me to explain the difference between tensile strength and yield stress. I'd spent hours walking him through the metallurgical testing lab, showing him how stress fractures propagate through aluminum under cyclic loading. He'd taken notes like his life depended on it, asking follow-up questions about grain structure and material fatigue coefficients. Now he was Ford's golden boy with an MBA from Northwestern and a plan to cut our safety margins by 40%. His presentation slides were polished, full of consulting firm buzzwords and statistical models that looked impressive to executives who'd never held a micrometer. The new casting method eliminates redundant inspection points, Brady continued, clicking to a cost breakdown chart. We'll save $230 million annually by removing Garrett's legacy checkpoints. That's what he called the stress tests that had caught 847 defective castings last quarter, each one a potential lawsuit, each one a family driving home in a truck that could fail at 70 miles per hour. I'd seen what happens when a suspension component fails catastrophically. The wreckage photos from the INSA investigation in 2018 were still locked in my desk drawer. A father and his 12-year-old daughter coming home from a baseball game. When the front A arm snapped on I-94, I adjusted my safety glasses and leaned back in my chair. The machining sounds from the plant floor filtered through the conference room walls, a steady rhythm I'd been hearing for over 2 decades. That rhythm told me when something was wrong before any computer screen did. Brady heard Excel spreadsheets. I heard metal fatigue. The Ford executives nodded along as Brady outlined his modernization strategy. Cut inspection time by 60%, reduce material testing from 3 samples per batch to 1, approve parts based on statistical confidence intervals instead of actual measurements. It was everything I'd seen go wrong at other plants, wrapped up in consultant speak. James Fletcher, Ford's VP of Procurement, leaned forward. What's the risk assessment on reduced inspection cycles? Brady had his answer ready. Our statistical analysis shows failure probability remains within acceptable parameters. The current process over-engineers for scenarios with extremely low occurrence rates. I wanted to interrupt to explain that those extremely low occurrence rates represented real people driving real trucks. But I'd learned over 23 years that when executives are looking at cost savings, engineering caution sounds like fear, questions. Brady asks, scanning the room with that MBA confidence. I kept quiet. In quality control, you learn to listen first, measure second, react third. The variable you miss is usually the one that kills you. After the meeting, Brady cornered me in the hallway. His tone had shifted from presentation mode to something more personal, almost pleading. Garrett, I need you on board with this Ford initiative. Your resistance is creating friction with the executive team. My resistance is preventing recalls. The data doesn't support that level of caution anymore. He held up his tablet, showing some PowerPoint analysis with confidence intervals and probability distributions. We can maintain quality standards with 30% fewer inspection cycles. The math is solid. I pulled off my safety glasses and cleaned them slowly. It's what I do when I'm processing information that doesn't match the specs. The lenses had small scratches from 23 years of plant floor work, but they were still functional, unlike Brady's analysis. Brady, how many units did we reject last month? 847 out of 47,000? That's a 1.8% failure rate, well within industry tolerance. And how many of those 847 would have made it to a customer's driveway? He paused, and I could see him running calculations in his head. Statistically, the odds of complete failure are minimal. Most defects would manifest as gradual degradation, not catastrophic failure. Statistically, my ass. Each one of those castings had stress fractures that would have caused catastrophic failure within 18 months. You want to bet 847 families on your statistics? Brady's voice dropped to that MBA tone they teach in business school, measured, reasonable, slightly condescending. Garrett, I respect your experience, but you're thinking like a technician, not a strategic leader. Ford expects innovation, not paranoia. I slid my safety glasses back on. The lens clarity was perfect again. What Ford expects is parts that don't kill their customers. That evening, I drove home through the Detroit suburbs thinking about Brady's presentation. My son Jason was home from Michigan Tech for spring break, and I found him in the garage working on his '98 Mustang. He'd inherited my need to understand how things work, but unlike me, he trusted technology over experience. "Dad, how was work?" he asked, looking up from the engine bay. "Complicated. Your old man might be obsolete." Jason wiped his hands on a shop rag. "You've been saying that since I was in high school. What happened?" I explained Brady's efficiency initiative, the cost savings, the statistical confidence that everything would be fine. Jason listened with the attention he'd always given my engineering stories, but I could see him processing it differently than I did. "Dad, maybe Brady has a point about modernizing the process. Statistical process control is pretty advanced now. We're learning about machine learning applications and quality assurance." I looked at my son working under the hood, his hands black with engine oil, and felt something shift. Maybe this was what Brady felt like, caught between the old ways and the new reality. "Jason, let me ask you something. If that statistical model says there's a 0.2% chance of failure, and you're driving that Mustang with your girlfriend at 80 miles per hour, are you comfortable with those odds?" He straightened up, considering the question seriously. "Well, when you put it that way, that's the difference between theory and responsibility. Brady sees numbers. I see faces." 3 weeks later, Brady got his approval. The new streamlined process launched with great fanfare. Press releases about cutting-edge efficiency, executive bonuses tied to cost savings. My quality team was cut from 8 people to 3. Sarah Martinez, who'd been with me for 12 years, got transferred to inventory management. Tommy Rodriguez, our best metallurgical analyst, took early retirement rather than work under the new protocols. I watched them clean out their lockers with the same feeling I'd had when the plant next to us closed in 2009. That hollow ache of watching competence get replaced by spreadsheets. But here's what nobody talks about in business school. Aluminum doesn't care about your projections. It follows metallurgical laws that existed before humans invented spreadsheets. When you skip the stress analysis on a suspension component, you're not optimizing efficiency. You're building a time bomb. The first red flags appeared within a week. Parts that should have been rejected were getting approved. I found Brady in the lab one Tuesday morning, signing off on a batch of castings that had visible surface defects, small pits that indicated subsurface porosity. In automotive applications, porosity is a death sentence. Air pockets create stress concentration points that propagate into cracks under cyclic loading. "Brady, these castings failed the porosity test." He looked up from his tablet where he was reviewing production metrics. "The surface imperfections are within acceptable tolerances according to the new standards." New standards based on what data? Statistical modeling that accounts for the relationship between surface defects and structural integrity. The algorithm predicts these parts will perform adequately for the required service life. I picked up one of the castings and held it under the inspection light. The surface looked like Swiss cheese, dozens of tiny pits that went deeper than the coating thickness. "Brady, this part will fail within 6 months of installation." The porosity creates stress risers that'll crack under normal load cycling. Your assessment isn't supported by the statistical analysis. My assessment is supported by 23 years of watching parts fail in the real world. But Brady had already moved on to the next batch, signing approvals with the mechanical efficiency of a machine. I started documenting everything that day. Not because I'm vindictive, but because in quality control documentation prevents disasters. When the first failure analysis came back showing microfractures in Brady's approved castings, I logged it. When the Ford inspector asked questions about our test protocols, I recorded those conversations too. Michigan is a one-party consent state. That means if I'm part of a conversation, I can record it legally. After 23 years of preventing catastrophes, you learn to build evidence like you build quality systems, methodically, completely, and with full traceability. Hugh Morrison, Ford's quality inspector, had been making more frequent visits to our plant. Hugh was old school like me, 28 years of experience, and an eye for problems that could spot defects in poor lighting. During his visit in early April, he pulled me aside after reviewing our new process documentation. "Garrett, I'm seeing some concerning trends in your recent shipments. Microcrack propagation that suggests insufficient stress testing. I've been documenting the same issues. Brady's new process is approving parts that shouldn't leave the plant." Hugh nodded slowly. "Can you walk me through the changes in your inspection protocols?" We spent an hour in my office going through the before and after comparison. Hugh's expression grew darker as I explained how Brady had eliminated critical test points, reduced sample sizes, and replaced metallurgical analysis with statistical modeling. This isn't just cutting corners, Hugh said finally. This is systematic negligence. Ford's liability exposure is enormous if these parts fail in service. What can we do about it? Keep documenting everything. And if you get any evidence of Brady knowingly approving defective parts, I need to see it immediately. The recording that changed everything happened during Brady's monthly review meeting with CEO Patricia Kane. I wasn't supposed to be there, but the conference room door didn't close properly. The acoustic properties of our building meant conversations carried through the ventilation system to my quality lab, a quirk of 1980s industrial architecture that the HVAC contractor never quite resolved. Brady's voice was clear through the air ducts, the old man's fighting every efficiency improvement. Garrett's quality obsession is costing us the Ford renewal. Patricia's response was cautious. What's his specific objection to the new process? He claims our new protocols create safety risks. But I've run the statistical model's failure probability is within acceptable parameters. The cost savings are substantial. Has he documented specific defects that would support his concerns? Some microfracture analysis, but nothing that would cause immediate failure. Garrett's applying aerospace-grade standards to automotive components. It's operational paranoia that's threatening our competitive position. I hit record on my phone. In quality control, when you hear variance from specification, you document it. The conversation continued for 18 minutes. Brady laid out his plan to transfer me to special projects, corporate code for firing someone without triggering unemployment benefits. He wanted my quality team disbanded, my inspection protocols eliminated, and my legacy thinking removed from operations. He painted a picture of me as an aging technician who couldn't adapt to modern manufacturing realities. Ford's renewal depends on hitting cost targets, Brady explained. Garrett's resistance threatens a $1.8 billion contract and 450 jobs. Sometimes difficult personnel decisions are necessary for the greater good. What Brady didn't know was that I'd been having side conversations with Hugh Morrison about the declining quality metrics. Hugh had noticed the same patterns I was documenting: increasing defect rates masked by statistical manipulation, approval signatures on parts that failed basic stress tests, and a systematic relaxation of safety standards that put Ford's reputation at risk. That night, I sent Hugh the recording with a simple message. Thought you should hear this. His response came back in 6 minutes. Can you provide metallurgical data on the castings approved under the new process? I need documentation of everything Brady signed off on. I could. I've been documenting everything for 3 weeks. Stress analysis reports showing microfractures, tensile test results outside acceptable parameters, approval signatures on parts that should have been rejected, a complete audit trail of Brady's efficiency improvements. The evidence painted a clear picture of systematic fraud. Hugh called me at 7 a.m. the next morning. Garrett, I need you to walk me through every casting lot approved since the new process started. Can you meet me at your lab in an hour? We spent 4 hours in my metallurgical testing facility, reviewing test data, examining rejected parts, and analyzing the evidence I'd accumulated. Hugh brought his own portable hardness tester and ultrasonic flaw detector, equipment that could verify my findings independently. We pulled samples from 12 different production lots that Brady had approved over the past month. The results were damning. Parts with tensile strength 15% below specification, castings with internal voids that would propagate into cracks under normal loading, surface treatments that hadn't properly bonded, creating galvanic corrosion sites. Hugh's expression grew darker with each failed component we examined. This isn't a quality issue, Hugh finally said, setting down a casting that had failed the ultrasonic test. This is systematic fraud. These approval signatures certify safety standards that weren't met. He pulled out his phone and took photos of each defective part, along with Brady's approval documentation. Garrett, what I'm seeing here represents criminal liability. Brady's not just cutting corners, he's knowingly certifying defective parts as safe for highway use. What happens now? Now Ford launches an immediate audit of every part shipped under this process, and Brady's going to learn what happens when you lie to automotive safety regulators. Hugh spent the rest of that day interviewing my remaining quality team. Maria Santos, one of the technicians who'd survived Brady's cuts, confirmed what I'd been documenting. Mr. Morrison, we've been flagging these defects for weeks, but Brady overrides our rejections. He says the statistical model accounts for the variations we're seeing. Has anyone explained to Brady what these variations mean in terms of structural integrity? Mr. Whitfield has tried, but Brady dismisses it as legacy thinking. He tells us the computer models are more reliable than human judgment. Hugh made notes in his inspection report, building a case that would reach beyond our plant to Ford's corporate safety division. Maria, I need you to document every interaction you've had with Brady regarding rejected parts, dates, times, specific technical discussions. That afternoon, Hugh met privately with Patricia Kane. I wasn't present for that conversation, but I could see the Ford inspector's black sedan in the executive parking lot for over an hour. When he emerged, Patricia looked like someone had explained that her company was sitting on a liability time bomb. The Ford audit team arrived the next Tuesday morning. 3 engineers, 2 lawyers, and 1 federal safety inspector from NHTSA. They spent 8 hours in our plant, reviewing documentation, interviewing staff, and examining the castings Brady had approved. The federal inspector, a woman named Dr. Elizabeth Turner, not the politician, but a metallurgical engineer with 20 years of INSA experience focused specifically on the stress analysis data. Mr. Whitfield, can you explain the discrepancy between your test results and Mr. Ashford's approval decisions? I walked her through the metallurgical lab, showing her the equipment we used for stress testing, the standards we'd followed for 23 years, and the new protocols Brady had implemented. Dr. Warren examined our testing procedures with the thoroughness of someone who'd investigated catastrophic failures. Your stress analysis shows clear evidence of fatigue crack initiation sites. How did Mr. Ashford justify approving these parts? He said statistical modeling showed the failure probability was within acceptable parameters. Dr. Warren picked up one of the rejected castings and examined it under our optical microscope. The microcracks were visible at 40x magnification, hairline fractures that would propagate under cyclic loading. Mr. Whitfield, these defects represent imminent failure risk. There's no statistical model that would classify this as acceptable. She turned to the Ford audit team. We're looking at potential criminal liability for knowingly shipping defective safety components. I'm recommending immediate recall of all parts approved under the new process. By Thursday morning, Brady was escorted out by security. I watched from my lab window as he carried his personal items to the parking lot, flanked by 2 guards. His MBA confidence was gone, replaced by the hollow look of someone who just realized that reality doesn't negotiate with spreadsheets. By Friday, the FBI opened an investigation into fraudulent safety certifications. Federal agents interviewed our entire quality team, focusing on Brady's decision-making process and his dismissal of our technical concerns. Agent Rodriguez, who led the investigation, had experience with automotive fraud cases. Mr. Whitfield, we're building a case for willful endangerment and conspiracy to commit fraud. Mr. Ashford's actions weren't just negligent, they were criminal. By the following Monday, Ford suspended our contract pending a complete operational review. 450 jobs hung in the balance while federal investigators determined whether our company could be trusted with safety-critical components. Patricia Kane called me into her office that afternoon. She looked like she'd aged 5 years in 1 week, the kind of accelerated aging that comes with realizing your company nearly killed people. Garrett, I owe you an apology and an explanation. I adjusted my safety glasses and waited. When tolerance specifications are exceeded, you let the other party define the corrective action. Brady convinced me that your quality standards were preventing growth. He presented compelling analysis showing we could maintain safety while improving efficiency. The cost savings were substantial, minus $2.3 million annually. The analysis was wrong. The analysis was fraudulent. He falsified test results, approved defective components, and created liability that could have destroyed this company. Worse, he put innocent people at risk. She pulled out a manila folder. Ford is offering us a path back to contract compliance. They want you as VP of Quality Assurance with full authority over all manufacturing processes, complete oversight of production standards, hiring authority for your quality team, and direct reporting to Ford's safety division. I cleaned my safety glasses again, thinking through the implications. More authority meant more responsibility. More responsibility meant more exposure when things went wrong, but it also meant control over the systems that kept people alive. What about the 450 jobs? Contingent on Ford's confidence in our quality management, they want assurance that what happened with Brady can never happen again. Your reputation is the only reason they're giving us this chance. I thought about the casting line downstairs, the rhythm of the machines, the weight of responsibility that comes with every approval signature. In quality control, you don't just prevent defects, you prevent disasters. You stand between corporate pressure and human safety, making decisions that matter more than profit margins. I'll take the position, but I want authority to rebuild the quality team, reinstate full inspection protocols, and establish direct reporting to Ford's safety division. No interference from operations management, no pressure to meet arbitrary cost targets. Done. You have complete autonomy over quality operations. That evening, I called Jason at Michigan Tech to tell him about the promotion. He'd been following the FBI investigation in the news. Automotive fraud cases make headlines in engineering circles. Dad, I'm sorry I suggested Brady might be right about modernizing the process. Don't be sorry. You made me think about whether I was being too cautious. But there's a difference between embracing new technology and abandoning proven safety standards. That was 18 months ago. Brady Ashford pled guilty to federal charges for fraudulent safety certification and criminal endangerment. He received 3 years in federal prison and $500,000 in fines. The judge's sentencing statement was clear. Your actions endangered thousands of innocent families for corporate profit. This court will not tolerate such callous disregard for public safety. Our plant is now running at full capacity with a quality team of 12 engineers. I rebuilt the department from the ground up, hiring experienced metallurgists and bringing back the inspection protocols that had protected families for over 2 decades. Sarah Martinez returned from inventory management to become my deputy quality manager. Tommy Rodriguez came out of retirement to train the next generation of stress analysts. The new quality lab is state-of-the-art digital microscopes linked to computer analysis, ultrasonic testing equipment that can detect flaws smaller than human hair, and tensile testing machines that can simulate 20 years of road stress in 48 hours. But the most important improvement isn't technological, it's philosophical. Every engineer on my team understands that their signature on an approval form carries the weight of human lives. Last month, Hugh Morrison brought a delegation of Ford executives through our facility for the annual supplier review. They watched our inspection process, reviewed our documentation protocols, and examined the thoroughness of our safety testing. The visit went 3 hours longer than scheduled because the Ford team kept asking questions about our procedures. This is what quality assurance looks like, Hugh told the group, standing next to our new stress testing station. Every casting gets full metallurgical analysis. Every test result gets verified by 2 engineers. Every approval signature carries personal accountability. James Fletcher, Ford's VP of Procurement, the same executive who'd listened to Brady's cost-cutting presentation 18 months earlier, asked about efficiency metrics. His tone was different now, more respectful of the process. Our rejection rate is 2.1%. I replied, sliding my safety glasses up to check the test data on my screen. Each rejected part represents a family that doesn't have to worry about suspension failure at highway speeds. Fletcher nodded. What's your cost per unit compared to the streamlined process? $23 more than Brady's approach, which is $2.3 million less than a single recall lawsuit, and infinitely less than the cost of explaining to a father why his daughter died because we decided a stress test was operationally paranoid. The Ford delegation spent another hour reviewing our quality metrics. 0 defects shipped in 18 months, 0 customer complaints, 0 warranty claims related to structural failures. The numbers told a story that MBA spreadsheets couldn't capture, that real quality doesn't cut corners. During the exit interview, Fletcher pulled me aside. Garrett, Ford is expanding our partnership with TechCast. We're awarding you the contract for our new electric truck line minus $3.2 billion over 5 years. But more importantly, we want your quality standards to become the template for all our suppliers. I adjusted my safety glasses, feeling the weight of that responsibility. James, I appreciate the confidence, but understand what you're asking. My standards aren't negotiable. No statistical modeling substitutes for physical testing. No cost pressure overrides safety protocols. That's exactly why we want you leading this initiative. My son Jason graduated from Michigan Tech with his mechanical engineering degree and accepted a position as a quality engineer on my team. His first day, I walked him through the same metallurgical lab where I'd trained Brady 3 years earlier. But this time the conversation was different. Dad, I understand now why you fought Brady's changes. In school, they teach you about statistical process control and lean manufacturing, but they don't teach you about looking a customer in the eye and knowing your work kept their family safe. Jason's generation brings fresh perspectives to quality control, digital analysis tools, predictive modeling, advanced material science, but they also bring the same fundamental respect for human life that drove me to document Brady's fraud. The technology changes, but the responsibility remains constant. Last week, we hosted a delegation from the National Institute of Standards and Technology. They're developing new automotive safety standards based on our quality protocols, procedures that will be mandatory for all federal vehicle contracts. Dr. Elizabeth Turner, the NHTSA inspector who'd investigated Brady's fraud, led the review. Mr. Whitfield, your documentation standards have become the gold standard for automotive quality assurance. We're recommending your protocols for adoption across the entire industry. The irony wasn't lost on me. Brady had called my methods obsolete, but they'd become the foundation for next-generation safety standards. Sometimes the old ways persist because they work, not because they resist change. These days, when young engineers ask me about balancing efficiency with safety, I tell them the same thing I wish someone had told Brady. In manufacturing, there's no statistical model for the moment a father loses control of his truck because you decided a stress test was operationally paranoid. The machines downstairs maintain their rhythm. The quality team runs every test, and 450 families go home every night because we remember that some tolerances can't be negotiated with. Brady's efficiency improvements would have saved $230 million annually. His fraudulent approvals created $47 million in potential liability and put 15,000 vehicles at risk of catastrophic failure. The FBI investigation revealed that similar cost-cutting schemes at other automotive suppliers had resulted in 23 deaths and 847 serious injuries over the past decade. The real cost of cutting corners isn't measured in dollars, it's measured in lives. If you've ever worked in a place where someone with an MBA and a PowerPoint presentation tried to convince you that your experience doesn't matter, you know what I'm talking about. They'll show you charts and statistics and efficiency models, but they can't show you what happens when quality controls fail in the real world. Your experience isn't obsolete. Your caution isn't paranoia. Your insistence on doing things right isn't resistance to change. It's protection for people who trust that you'll stand between them and corporate shortcuts. Don't let anyone convince you that cutting corners is innovation. Real innovation finds ways to do things better without compromising safety. And if someone tells you that your standards are legacy thinking, remind them that some legacies exist because they keep people alive. The next time someone in a conference room points a laser at your name and calls your methods obsolete, remember that their PowerPoint slides don't trump the laws of physics. Stand your ground, document everything, and never forget that somewhere out there, families are driving home safely because you refuse to negotiate with tolerance specifications.